we have learned to solve systems two different ways so far. The first way was by graphing, where we graphed each of our equations on an x, y axis to figure out where the lines intersected. Then we learned that sometimes some graphs or some systems aren't real easy to graph, so we had to look for alternative ways. And what was the next method we learned? Substitution, as we did yesterday. There's going to be times when substitution's not going to be very nice. What if you have an equation that doesn't have a coefficient of 1 or -1? It's not real easy to solve for. Then you've got all these fractions. That's not always the ideal way to go, is it, if you're going to involve? Sometimes you have to. There's no other way around it. But there is one other option we have, and that's called elimination. And I really think you guys are going to like this better than substitution or graphing. I think it's going to become a little easier for you. Hopefully you'll be successful at it. So this is called elimination. I'm going to go ahead and have you copy down these two equations before we discuss elimination. In order to perform elimination, you must have opposite terms, or sometimes we call those additive inverses. The city is doing a tornado drill. They're just testing the sirens. In order to do eliminations, you need to have opposite terms. So what do I mean by opposite terms? Or additive inverses? What is the additive inverse of 2x? What can I add to 2x that gives me 0? Negative 2x. What about negative 4y? What can I add to negative 4y that'll give me 0? Positive 4y. In order to do elimination, you must have opposite terms. If you don't, you can't do elimination. It doesn't work. So in our first example that we're looking at, do we have opposite terms?
No.
Yes.
Yes.
Don't we have a positive y and a negative y?
Yeah.
If I add those two together, isn't it going to give me 0?
Yeah.
Absolutely. And that's what we do in elimination. We add the two equations. We line them up and we add them. Line up your x's, your y's, and your constants. Now add. 3x plus 2x is 5x.
Go the other way.
What do you mean?
Like on these outcomes, I just turn on the right.
You could. It doesn't matter. When I add y and negative y, that's going to cancel out. Those are going to be eliminated. Guys, if one of your variables does not eliminate, you can't just randomly add them or cross them out. They have to be eliminated in order for them to be gone. 5 plus 10 is 15. Now, can you solve this equation?
Yeah.
You should be able to. Divide both sides by 5, so x is 3. X is 3. When we solve systems, we know that we're going to write our answer as an ordered pair. So it's 3, comma, something. What is that something going to be? Well, we need to figure it out. How did we figure it out in substitution what that other coordinate's going to be?
Put it back.
Substitute it back in. And that's what we're going to do here as well. We're going to put the value of x, which is 3, back into one of the equations. It doesn't matter if you use the first equation to substitute there, or if you use the second equation to substitute there. Totally your preference. I'm going to use the first equation. I'm going to put 3 in for x. Now I can solve. 3 times 3 is 9. Plus y equals 5. Subtract 9 on both sides. Y is equal to negative 4. So my solution is 3, negative 4. How could I check to be certain that this is right? Substitute it back in. You guys, this can be a quick mental check. I know that x is 3, so 3 times 3 is 9. Y is negative 4, so 9 plus negative 4, is that 5? It is. Put 3 in for the x in the second equation. 2 times 3 is 6. Minus a negative 4. Minus, Randy, are you with us?
Yeah.
Minus a negative 4 is going to be plus 4. So 6 plus 4 is 10. It can be a quick mental check, but please check your work to be certain you've got the right answer. Look at the next example. X plus 2y equals 4. and negative x plus y equals negative 1. Can we use elimination here?
Yes.
We can, because we have opposite terms. These are also called additive inverses. If I add x plus a negative x, that's going to cancel or zero out. 2y plus y is 3y, and 4 plus a negative 1 is 3. Divide both sides by 3, y is equal to 1. So I know that I have a y coordinate of 1. Now find the x. Remember, you can substitute wherever you want. You could put it into the first equation for y, or the second equation for y. It does not matter. Let's use the first equation. X plus 2 times 1 equals 4. 2 times 1 is 2. Subtract 2 from both sides. X is equal to 2. So we have the coordinate of 2, 1. How about example 3? 4x plus 3y equals 16, and 2x minus 3y equals 8. Can we use elimination here?
Yeah.
Yeah. If we add these two equations, the y's will be eliminated. 4x plus 2x, 6x. If I take 3y plus a negative 3y, and we eliminate, and 16 plus 8 is 24. So divide both sides by 6, x is equal to 4. So now substitute back in to find y. I'm going to put 4 either into the first equation, 4x, or the second equation. Let's use the first equation. Four times 4 is 16. Solve this equation, I'll subtract 16 from both sides. 3y equals 0. Divide by 3, 0 divided by 3 is 0. And the ordered pair is 4, 0. 4, 0. Example 4. Can we use elimination?
No.
Yes.
Yes or no?
No, that's not negative.
We don't have opposite terms. We don't have additive inverses. I could use substitution, but I want you to use elimination here. So are there any thoughts as to how we can make opposite terms? Jess?
Divide one of the problems by negative.
Very good. We could divide one of the equations by negative 1. What's another option instead of dividing by negative 1? Multiply by negative 1. I'm going to go ahead and multiply because typically that's what we'll do instead of dividing. So I'm going to pick one equation. It really doesn't matter which one, because you don't want them to be a negative x, one to be a positive x. I'm going to multiply that second equation by a negative 1. So that gives me negative x minus 3y equals a positive 10. And remember, when you multiply an equation, you multiply every single term in that equation by a negative 1. Don't pick and choose what you get to multiply. Multiply everything. Now add the two equations. I'm going to cross off this middle equation. It's no longer part of our system. Now if I add, do I have opposite terms? Additive inverses? I sure do. X plus a negative x. That's going to zero out, isn't it? 6y minus 3y. 6 minus 3 is?
Negative.
Positive 3y. 5 plus 10 is? 15. Divide by 3. Y is equal to 5. At this point, we need to substitute back in, and we really have three choices. We could use one of the original two equations, or we could use that new third equation. It really doesn't matter. I'm going to pick the first equation. X plus 6 times 5 equals 5. 6 times 5 is 30. Subtract 30. X is equal to a negative 25. So our solution is negative 25, comma, 5. Can I use elimination on an example 5?
No.
Not currently, but there's something we could do to make it possible. Which one?
The bottom one.
Okay, so hang on, before you guys do that, if you multiply the second equation by negative 1, what variable will be eliminated? The y. What if we wanted to eliminate x? What, Haley? You could, but that's going to give you 1/2 y.
Multiply by +2
Where?
on the top one.
Good, Brady. You could multiply the top equation by a positive 2. That would give you, well, if you multiply by a positive 2, wouldn't that give you a negative 2x here? So then the x's would eliminate. Does it matter which variable we eliminate? No, it doesn't. I heard multiply by negative 1 first, so we're going to do that first. Let's multiply the first equation by negative 1. So negative x times negative 1 is positive x. Negative 1 times y is negative y. Negative 1 times 1 is negative 1. Now add the equations together. 2x plus x is 3x. If I add the y's, they're going to be eliminated. Equals negative 3. Divide both sides by 3. X is equal to negative 1. I'm going to substitute into, I think I'm going to use the first equation just to show you what I would do with that negative. But really any of these 3 equations would be fine to substitute into. If I use the first equation, it's the opposite of negative 1 plus y equals 1. What is the opposite of negative 1? Positive 1. So I'll subtract 1. Y is equal to 0. Negative 1, 0. And like I said previously, you can always check your work by plugging that ordered pair back into both of the equations. Alright, do you guys like elimination better than substitution? And to me, it just flows nicer. Substitution, you got to really think about what variable you're solving for, plugging into which equation, or which variable. Elimination, you just need to have those additive inverses. You need to have a positive and a negative of the same term. Okay, I'm going to stop here and give you guys an opportunity to get your homework done in class. Hopefully you'll have a day of no homework if you get this finished. We're on page 352 out of your book. Working problems 7 through 18. 7 through 18.